let's talk about how to prove that this limit equals 1. In order for us to prove this statement, we will need to use some geometry together with a squeeze theorem. We have a picture here where we have a triangle AOB contained in the sector AOB, which is contained in a bigger triangle AOD. We can take a look at sine of x in this small right triangle BOC. That is going to be the opposite side BC over the hypotenuse OB. But because we know that OB is exactly the radius of the circle equals 1, so we have sine of x equals exactly the length of BC. Similarly, we can take a look at tangent of x in this bigger triangle AOD. That's going to be the opposite side AD over the adjacent side OA. And because we know OA is the radius of the circle equals 1, so we have tangent of x equals exactly AD. After we have this information, we can start to do some calculation of the area of this triangle and this sector and the bigger triangle. We have area of triangle AOB equals 1/2 times OA, which is the base, times the height BC, which is 1/2 times 1, and then BC, we know that is sine of x. And then we can calculate the area of the sector. Sector AOB. That's going to be x divided by 2 pi multiplied with pi times 1 squared. Where this x divided by 2 pi represents the fraction of this circle, which is this sector, this slice take out of the entire circle, the portion of that. Because we know a full circle has a radius 2 pi, and this slice is not taking the full radius 2 pi. It only takes that much radius, which is x, out of the radius of the entire circle 2 pi. So that's the kind of the fraction of the circle. And we use this fraction to multiply with the area of the entire circle, which is pi r squared, to obtain the area of this sector. And we can simplify this expression by canceling the pi, so we will have x divided by 2. Okay, so next we can calculate the area of this big triangle AOD. AOD will be 1/2 times the base OA, and then times the height AD. We know OA equals 1, and then AD has been previously calculated, so tangent x, so we have that. The reason why we calculate the area of these things is because we want to construct an inequality so that we can use the squeeze theorem later. By observation, we can see that this triangle AOB is contained in this sector AOB, which is contained in the bigger triangle AOD. So we're going to have the relationship between among the areas. We have the area of this will be less than the area of that, which is less than the area of this. So the inequality that we can construct is 1/2 sine x less than 1/2x less than 1/2 tangent of x, which is exactly what we need. And then we will multiply this inequality by 2 to get rid of the fraction. So we have this. And then we want to divide all the terms by sine of x. And because we know sine of x is going to be greater than 0, so that does not change the direction of the inequality. So 1 divided by x sine of x less than tangent of x divided by sine of x. We can simplify this a little bit to write this tangent divided by sine by 1 over cos. Okay, so then we have this x divided by sine of x squeezed in between these two functions, which is upper bound and a lower bound. And then we can apply the squeeze theorem to calculate the limit of both functions. Limit of this equals limit of this upper bound, which equals 1. Okay, so by the squeeze theorem, we have that the limit of the function in between must also approach the same limit, which is sine of x is equals 1. And then we take the reciprocal on both sides of this equation to have limit of sine of x divided by x equals 1, which is exactly what we were trying to prove.